Imagine a flying skyscraper that weighs as much as hundreds of cars, costs as much as a business district, and can carry a payload that no other aircraft on the planet can handle. This is the Antonov AN-225 MYA. Until 2022, it was the largest aircraft in history and served a single purpose: to lift into the sky what the rest of humanity deemed too large. It is approximately 84 meters, 275 feet long. If you stand at the nose on the ground, you simply won't be able to see the tail. Its wingspan is about 88.5 meters or 290 feet, wider than an American football field with both end zones. Music maximum takeoff weighed up to 1.4 million pounds, about 640 tons. It's like taking roughly 160 ordinary cars, assembling them into one giant object and telling it, "Now you're an airplane, fly." Today we'll dissect this dream machine like a luxury supercar. How much did it weigh? How did it even take off? What cargo did it carry? And why did its demise cost not only money, but an entire era? Welcome to the channel for the wealthiest. A colossus larger than any other aircraft. From below, the Maria looks like a building that was accidentally placed on wheels. The fuselage stretches 275 feet, or about 83.8 meters. That's longer than the wingspan of a Boeing 747. To lift such a weight, engineers had to build a wing with an area of about a quarter of an acre, or roughly 10,000 square feet. That's roughly 900 square meters of metal that literally clings to the air to hold up the impossible. For people accustomed to private jets, the GAL isn't an airplane, but a flying industrial plant, where the wings are too large to see in their entirety. These dimensions create not only awe, but also very costly problems. From the cockpit, the pilots cannot see the tips of the wings at all. Each wing extends 145 feet, about 44 meters, to the side. It's like a 10-story building pushed sideways away from you. And all of this has to fit on a standard concrete taxiway. The solution was to raise the cockpit high on the nose, almost like a super yacht's bridge. The pilots sit above deck level to at least somewhat control the edges of the taxiway, but even that isn't enough. That's why every takeoff and landing is a mini operation. Wing guides walk alongside, people on the ground who watch to make sure the giant wingtips don't hit the terminal or a pole. No camera provides as much information as these few people, on whose decisions an aircraft worth hundreds of millions sometimes depends. Double tail. When an aircraft carries another aircraft on its back, you can recognize regular airliners by a single vertical fin at the rear. With the AN-225, everything is different. Two vertical planes, each about 60 feet, 18 meters tall, protrude from the rear, and they are mounted at the edges of a huge horizontal stabilizer. Why is that? Because this aircraft was originally built not just as a cargo plane. It was entrusted with another gem of Soviet space exploration, the Buran space shuttle. And this shuttle had to be carried right on its back. A single conventional tail fin would have been completely blocked by this load and would have ceased to function. That's why the engineers split the tail into two towers at the edges. This way, control is maintained even if you have an entire spacecraft about 118 feet long, roughly 36 meters, parked on top. This is a level of engineering tuning that even the owners of the craziest hypercars would find hard to imagine. 6 engines capable of lifting a small house. 6 engines hang beneath the Maria's wings, 3 on each side. Each is a massive D18T turbofan, producing about 51,600 pounds of thrust, roughly 230 kilonewtons. That's roughly equivalent to a single engine on a Boeing 777. Together, these 6 monsters generate about 309,600 pounds of thrust, or roughly 1.37 kilonewtons. For comparison, a classic Boeing 747 produces approximately 266,000 pounds. The AN-225 is 16% more powerful. This power isn't used for speed, but for the ability to lift a monstrous weight. But the real magic isn't in the numbers at all, but in how they do it. A massive stream of air enters the engine nacelle, and about 85% of that air doesn't burn at all. It is simply accelerated by a giant fan and expelled backward, creating thrust. To put it simply, it's like a massive room fan with a diameter of about 7.5 feet, approximately 2.3 meters, spinning at breakneck speed, only surrounded by steel and fueled by kerosene. Only the remaining 15% of the air passes through the engine's fiery core, where it is compressed in 14 compressor stages to a pressure about 24 times higher than normal atmospheric pressure. There, the kerosene and air are transformed into a flame with a temperature of about 2,900 degrees Fahrenheit, roughly 1,600 degrees Celsius, spinning the turbine, and once again, that same giant fan at the front. 6 such systems operate simultaneously. This is no longer just an airplane. It is a mobile power plant on wings. Its fuel consumption is such that a single flight uses as much kerosene as several swimming pools. Such power comes at a high cost, literally. The MR-1's fuel tanks held approximately 96,000 US gallons, or about 363,000 liters of kerosene. That's nearly 5 average-sized swimming pools, completely filled with aviation fuel. At cruising altitude, the 6 engines consume about 4,200 gallons per hour, roughly 16,000 liters of fuel. Imagine every 60 minutes enough fuel to fill approximately 280 passenger cars disappears. And all of this just to keep this flying skyscraper from simply falling. If the aircraft isn't fully loaded, these reserves are enough for about 18 hours of flight and a range of approximately 8,300 miles, or about 13,500 kilometers. But fill the cargo hold to the brim, and the range drops to about 3,480 kilometers. That still seems like a lot, but for intercontinental missions, refueling stops must be planned, much like private jets flying halfway around the world. Every extra kilogram of cargo means fewer kilometers of range. In the world of ultra-expensive aviation, the equation is simple. Want to carry more? Pay with either fuel, time, or money. The birth of a dream, when a country needs its own space limousine. This behemoth didn't appear by accident. In the early 1980s, the Soviet Union needed its own answer to the American shuttle. The Buran appeared, and with it came a problem: how to transport the spacecraft from the factory to the Baikonur Cosmodrome. The designers already had the AN-124 at their disposal, also a giant, the largest military transport aircraft of its time. But even it couldn't carry the Buran on top, as the American 747 shuttle did. So the Antonov Design Bureau took the AN-14 and simply scaled everything up. The fuselage was lengthened by about 7 meters. The wingspan was extended by another 15 meters, and the 4 engines became 6. In December 1988, the new giant took off for the first time, and 3 months later, it was already carrying the Buran on its back to the Paris Air Show. At the time, it was a true demonstration of power. The country showed that it could even turn a spaceship into a piece of luggage. The largest safe container in the sky, but the most expensive magic of the Maria was not on its back, but inside. The AN-225's cargo compartment is the largest enclosed space ever to take to the skies. Its internal dimensions are approximately 142 feet long, about 43.3 meters, 21 feet wide, about 6.4 meters, and 14 feet high, about 4.3 meters. Imagine a tunnel longer than the fuselage of a Boeing 737 into which a truck can easily drive. The total volume is approximately 1,300 cubic meters. Inside, you can fit up to 16 standard, approximately 12 2-meter shipping containers, arranging them in 2 rows of 8. Why all this? Because some cargoes in the world are so expensive and massive that they cannot be disassembled, transported by rail, or shipped by sea without risk. Generators weighing 150 tons each. Industrial turbines larger than some houses. Emergency humanitarian aid that would only fit into an entire fleet of conventional aircraft. Whenever someone in the world said, "We need to transport this and nothing short of a miracle will help," they called Antonov and ordered an MRI. How do you get something heavier than a locomotive onto a plane? To load a hypothetical 150 to 200-ton generator onto the plane, simply opening the door isn't enough. The entire nose of the AN-225 lifts up. The massive front section of the fuselage tilts upward on hydraulic cylinders, as if the plane were yawning. This takes about 10 minutes after connecting the external power supply and checking the systems on the ground. It looks like a portal to another world. Before you lies a black hole measuring approximately 6.4 by 4.3 meters, large enough to swallow a small house. But the question remains, how do you move such a heavy load inside? The answer: the floor. 2 parallel rail tracks run the entire length of the bay. Rollers are built into them, along which special trolleys glide. And hidden between the rails in the floor are thousands of steel balls. Each one rotates freely in any direction. If you place a turbine weighing nearly 150 tons on this carpet of balls, a real miracle will happen. A load that would require a crane on a normal surface can be moved here with just your shoulders. 2 loaders, bracing themselves, literally roll something that weighs more than a locomotive. You need to move the load a couple of centimeters to the left so it doesn't bump into the power unit. Just push. The balls do their job and friction almost disappears. Aircraft loading. When hydraulics save lives and millions, another problem is the slope. Driving a 200-ton object up a steep ramp into the aircraft is a recipe for disaster. If the load shifts back even slightly, no winches can hold such a mass. A mistake could cost not only equipment, but also human lives. That's why the MRY has a trick that resembles the movement of a large dog tilting its head toward a bowl. The nose landing gear lowers slightly via hydraulics, while the main landing gear, conversely, extends. The fuselage tilts forward. The floor comes closer to the ground, and the ramp angle decreases significantly. After a few minutes, the massive machine seems to become lower. The ramp is almost level. Now a cargo weighing hundreds of tons can be rolled inside practically in a straight line, without acrobatics or deadly dangerous tilts. When a single mistake turns a cargo into a rocket, balance is everything inside the aircraft. If you simply place the cargo wherever it's convenient, the aircraft won't forgive it. Every square meter of the floor, walls, and ceiling is literally studded with tie-down points designed for tens of thousands of pounds, tens of tons of load, chains, straps, and nets. All of this is used to ensure that no object from a container to a turbine moves even a centimeter. The reason is simple. Every aircraft has a center of gravity, the point where all the weight converges. Shift it too far forward and the nose will dip downward, so the pilots won't be able to raise it. Shift it too far back. The plane will start to pitch its nose up until it crashes. Imagine a 50-ton load that starts sliding across the floor during turbulence. It instantly shifts the balance, and what was a stable flight turns into an uncontrollable maneuver. That is precisely why the Minaria's loading was handled by dedicated loadmaster specialists. They spent hours calculating the weight distribution, double-checking the figures several times. A mistake here means putting the plane at risk. the cargo, and the crew, all at once. Music. The maximum internal payload is about 550,000 pounds, roughly 250 tons. That is more than the American giant C-5 Galaxy can carry. And the Maria is also capable of carrying external loads on its back. Originally, it was a Buran, but theoretically, other structures can be attached on top. In theory, 551,000 pounds can be loaded inside and up to 440,000 pounds, about 200 tons on the outside. But humanity has not yet dared to undertake such a mission. A wing that defies the speed of sound. At speeds around 500 miles per hour, or roughly 800 kilometers per hour, the air begins to behave erratically, even if the aircraft hasn't yet reached the speed of sound. Areas of flow faster than Mach 1 can form over the wing. Small shock waves form there, which sharply increase drag. To prevent the aircraft from burning extra fuel fighting its own turbulence, engineers designed a wing with a special shape, known as a supercritical airfoil. Its purpose is to delay the moment when the air above the upper surface of the wing begins to break into supersonic flow, and to keep the flow as smooth as possible at a cruising speed of approximately 500 miles per hour, or about 800 kilometers per hour. Slots run along the leading edge of the wing, extending forward and downward during takeoff and landing to increase the wing's curvature. At the rear are massive Fowler-type flaps that don't just deflect but literally extend from the wing, increasing its surface area. Simply put, when it needs to take off or land, the wing inflates, becomes larger, and grips the air better. Thanks to this, the Maria can stay airborne at speeds at which a clean, unconfigured wing would have long since spun into a tailspin. Controlling the giant. Hydraulics under pressure strong enough to cut through steel. Ordinary small aircraft can be controlled by hand. The pilot pulls the control yoke and the mechanism moves small control surfaces. In the case of the AN-225, this is impossible. The aileron alone, the surface at the wingtip responsible for roll, is over 26 feet long, about 8 meters. Trying to turn it manually at 800 kilometers per hour is like trying to turn a door by hand in a hurricane. Therefore, all the controls are operated hydraulically with a working pressure of about 3,000 pounds per square inch, approximately 207 bar. This is about 100 times greater than the pressure in your car's tires. At such a pressure, the fluid in the piping could theoretically cut through the metal if the wall gives way. To ensure that the loss of a single circuit doesn't cost the plane, the Maria uses triple redundancy. 3 independent hydraulic systems. Even if 2 were to fail for some reason, the remaining one would allow the plane to make it home. 32 wheels so as not to puncture the runway right through. With a weight of about 640 tons, a concrete runway is not a monolith but a fragile structure. If all that weight were concentrated on just a few wheels, the Maria would pierce the runway like a pin. The pavement would simply crack. The solution: 32 wheels, 28 of which are main wheels arranged in 2 rows of 7 on each side of the fuselage, with 4 more in the nose. This distributes the load over such a large area that the specific pressure on the concrete is even lower than that of some aircraft half its weight. This is important for airports. Not every airport is ready to accommodate a flying skyscraper that could damage its runway. Each landing gear strut is equipped with nitrogen and hydraulic fluid shock absorbers. When hitting an uneven surface, the strut can compress up to 16 inches, approximately 40 centimeters, absorbing the impact. This is how the Maria protects not only its cargo, but also the fuselage itself from thousands of small impacts during taxiing and, of course, from the most critical phase of flight, landing. The legendary flight with Buran. On May 13, 1989, the Maria prepares for a flight that will go down in history. Attached to its back is the Buran spacecraft, 118 feet long, approximately 36 meters, and weighing about 137,000 pounds, approximately 62 tons. In total, that's about 1.23 million pounds, about 600 tons of high-tech metal. The aircraft accelerates down the runway at the Baikonur Cosmodrome. 6 engines engage takeoff thrust. The sound from them shifts from a roar to a low hum that makes the ground tremble. The acceleration doesn't feel abrupt when you have hundreds of tons under your wing. Even this thrust doesn't feel like a jolt, but rather a firm yet smooth pressure against your back. At a speed of about 100 miles per hour, roughly 161 kilometers per hour, the wings begin to take effect. The control column becomes slightly lighter. The wheels are still rolling on the concrete, but the weight on them decreases with every kilometer of speed. Liftoff occurs about 2.2 kilometers from the start of the runway. More than 2 kilometers of runway, then a smooth climb, about 1,000 feet, roughly 300 meters per minute. You can't go too high. The wind from above adds aerodynamic drag, so the cruising altitude is about 20,000 feet, about 6 kilometers. Speed is about 400 miles per hour, roughly 640 kilometers per hour. This 2,800-mile flight, approximately 4,500 kilometers with stopovers, proved that, yes, the world now has an aircraft capable of transporting spacecraft as if they were luggage. A day in the life of the Imriya. Regular flights after the collapse of the USSR were less spectacular, but no less ambitious. Antonov crews transported giant gas turbines, generators for power plants, wind turbine components, heavy emergency response equipment, and humanitarian cargo. Every such flight began not with takeoff, but with math. First, the cargo weight, then the required amount of fuel, then the runway length at the departure and arrival airports. The AN-225 required a minimum of about 10,000 feet, roughly 3 kilometers of runway at maximum weight. Not every airport can accommodate that. Even as they were climbing, the pilots were already thinking about the landing. What would the weight be by the end of the flight? How much fuel had been consumed and what approach speed was needed? At maximum weight, the speed on the final approach is approximately 160 kilometers per hour. The flaps and slats are extended in stages. The wing transforms into a massive parachute while the nose rises. The pilots constantly adjust the trim. The landing is more like a law-breaking maneuver. The massive aircraft approaches the concrete at the speed of a passenger car on the highway. First, the 28 main wheels touch down. The shock absorbers absorb hundreds of tons of weight as it shifts from the wings to the landing gear. A moment later, the nose gear lowers. Now the pilots can steer and brake more aggressively. 3 systems are used to stop the aircraft: reverse thrust on all 6 engines, aerodynamic drag from the flaps, and wheel brakes with an anti-lock braking system. From touchdown to a safe taxiing speed, a standard runway of about 6,000 feet, or roughly 1.8 kilometers, is sufficient. This is the world of big money and records. After the collapse of the Soviet Union, the Mriya became not a museum exhibit, but a private contractor in the realm of ultra-expensive logistics. Antonov Airlines used it as a heavy-lift charter aircraft. The list of records is impressive even to those accustomed to expensive toys. The heaviest single cargo ever lifted into the air was about 247 tons. The maximum total payload is approximately 253.8 tons. The longest cargo was about 138 feet, or roughly 42 meters in length. In the realm of luxury, it wasn't the aircraft itself, but the service. We'll deliver your one-of-a-kind item to places no one ever thought of transporting it to. Factories, power grids, and sometimes even entire regions depended on the price of a single contract for such missions.